angles. Okay, so I have this nice table laid out here for you where we're going to actually draw some examples and some non-examples just so you can see what's going on. So our first type of angle pair are adjacent angles. Okay, those are two angles that lie in the same plane. Okay, so your angles do have to lie in that same plane. And they have a common vertex. They share a common side. And they have no common interior points. And we did talk about what interior was yesterday. Okay, that's where the angle opens up and there's points on the inside of that angle. So an example of adjacent angles, that's bothering me, would be if I have, say this angle here, I have my two rays, right? An adjacent angle would be a third ray just coming off of the other two there. So they share this common vertex right here. I'll just call it vertex B. So they share vertex B. And they share this common side right here. If I put a point on that. So they share that ray BA. So your adjacent angles have to share that one ray. Do you see those? Yes, they're next to each other. So another word that I use for adjacent is next to. Okay, they're next to each other. Okay, a non-example would be if I have an angle here, and then I just had another angle off to the side. Okay, so those are two angles, but they're not sharing a vertex. They do have different vertices. So this one has vertex A, this one has vertex B. Okay, they don't share that vertex point. They don't share that ray in common. Okay, questions on adjacent angles? There's a lot of vocabulary in geometry. All right, so our next one is a linear pair. Okay, these are adjacent angles whose non-common sides form opposite rays. And we did talk about opposite rays yesterday. What do opposite rays do? Do you remember? They form a line. Okay, so these should form a line. So our adjacent angles should form a line. Now, angles in a linear pair are supplementary. Meaning they add to 180 because a line is 180 degrees. Okay, so in my example here, I'm going to start off with a line. Okay, because I know my two adjacent angles have to form a line. Then I have this ray that comes off that line. So here would be our common vertex of our adjacent angles. Okay, they share this common ray right here. And I'm going to label this first angle 1, second angle 2. So here I can see if I take the measure of angle 1, add it to the measure of angle 2, I should get 180 degrees. Okay, so if you ever see those two adjacent angles forming a line, it is called a linear pair. Okay, a non-example is if I have one angle here, we'll say that's 50 degrees. And if I have another angle, I'll make this one obtuse, over here, say that's 130 degrees. Now if I add those together, I still get 180, right? But they're not forming a straight line, so it can't be a linear pair. Okay, so A linear pair always has to form that line. Okay, they have to be adjacent angles. Does that make sense? Yes? Any questions on linear pairs? Okay, the next one on the front page here are vertical angles. Okay, so those are two non-adjacent angles formed by intersecting lines. Okay, so we have two lines intersecting. Now, vertical angles are always going to be congruent to each other. Okay, their measures are going to be equal. Okay, vertical angles are congruent. So an example of vertical angles, I need two intersecting lines. Okay, so here's one. Here's my second line, intersecting the other. I'm going to number each of my angles that were created. So I have angle 1, 2, 3, and 4. So angles 1 and 3 are vertical angles. They're the angles that are across from each other in your intersecting line. Okay, that's what vertical angles are. 2 and 4 are also vertical angles. So if I knew these were vertical angles because they're created by those intersecting lines, I could say angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Okay, so those two angles across from each other are your vertical angles, and they are always congruent. Okay, a non-example. Let's see. If I draw a line, we'll draw a ray coming off that line just like we did before. So this is a linear pair. But I'm going to look more at seeing if I can create these vertical angles here, or these non-vertical angles. If I draw another ray down here. Now these two angles are across from each other, right? But they're not vertical angles, okay? I'd have to make this a straight line for those two to be vertical angles. Okay, so if I label this 1 and 2, I would say angle 1 is not congruent, so we put a little slash through that congruency symbol to angle 2. Okay, so they're still across from each other, but they're not equal. Okay, they're not congruent to each other because they're not two intersecting lines. Okay, do you see the difference there? That one kind of gets a little bit confusing for some, and I'll see that on quizzes and tests where, well, they're across from each other, so they must be equal. So I can say that angle's also 50 degrees, but it's not. Okay? Any questions on those first 3 types of angle pairs? All right. Next type. We have complementary angles. Those are 2 angles to a sum of 90 degrees. Okay, complementary means they're adding together to be 90. Now you see this big X here? You don't have a non-example of this. Any 2 angles added together to be 90 are complementary angles. So I'm going to show you 2 different examples. So I'm going to split this in half. Excuse me. First one, we're going to make them adjacent complementary angles. Okay, so this is 90 degrees, right? Put my little box in my corner. Now I need 2 angles that add to that. So I'm just going to split that with 1 single ray. And I can label those 2 separate angles, 1 and 2. Now I know since that larger angle has to equal 90, I can add together angle 1 and angle 2 to equal 90. And again, that little m means the measure of. And we use that when we're actually talking about the degree of that angle. Okay, if I'm just saying angle 1 and congruency type deal, then we don't include the m, but since I'm talking about it equaling to an actual measure, we use the measure of that angle. Okay, so this is one way. So angle 1 is a complement to angle 2, they add to 90. Another example, my angles don't need to be adjacent. Okay, so I can have one angle here, and another one over here. Say this angle is 60 degrees, then this angle would have to be 30 degrees. If I add those two together, those are still complementary angles because they still add to 90 degrees. Okay, so for complementary angles, you don't have a non-example. Any two angles, doesn't matter if they're adjacent or not, if they add to 90, they are complementary. Questions? All right, next is supplementary. Okay, supplementary, we have two angles to a sum of 180 degrees. So again, we don't have a non-example of this, but I will show you again two examples, just like we did last time. So first example is if they are adjacent. Okay, so that means they're going to form a line, because if they're adjacent and they add to 180, have to form a line. I have a ray off that line. Label my angle 3 and 4. So these two angles, if I were to add them together, they should equal 180. So if I take the measure of angle 3 plus the measure of angle 4, I should get 180. Okay, and angle 3 is a supplement to angle 4. Okay, that means if I add angle 4 to it, I get 180. That's what supplement means, and that's what complement meant up here. If I add 2 to 1, I do get 90. Okay, so that's the adjacent example for supplementary angles. Again, they don't have to be adjacent. So my second example here, making my two angles we'll label this one as 100 just to make it easy, then this one's 80. Okay, they are separate, they have different vertices, but if you do add them together, they will still add up to be 180 degrees. Okay, questions on complementary or supplementary? Okay, easy way to remember the difference between the two, because students tend to get them flip-flopped. Complementary starts with a C, that comes before S in the alphabet, and 90 comes before 180 for our numbers. Okay, so 90 before 180, C before S. Yes? Good way to remember? All right, I want you guys to answer numbers 1 and 2 in your groups right here. Answer number 1 and 2 in your group.
Is this where we have to do the auto one? Okay.
So use the notes from the front to figure that out.
Oh, and your pair must form a line, like it has to form a line, but it's
all gonna
supplementary.
be like, yeah.
And then supplementary angles always form one more angles.
right, raise your hand. Anybody want to tell me what the answer to number 1 is? What they thought. Go ahead, Justin.
That a linear pair must form a line, but a supplementary pair doesn't.
Yes. So a linear pair must form a line. But supplementary angles, which is a long word, don't have to. Okay, so a linear pair, you have to form that line. Your angles must be adjacent to each other. Supplementary angles, they can be separated like our example right here. Okay, so they don't have to share that vertex or that ray to form that line. Alright, so then true or false, supplementary angles always form a linear pair. Using what you know from 1. Is that true or false? It is false. A linear pair is always supplementary, but supplementary angles are not always a linear pair. Okay, questions on 1 or 2? All right, then for 3, 4, and 5, we're using the supplement and complement of a given angle. So number 3, we're given the angle is 60 degrees, and we want to find its supplement, meaning we want to find what angle to add to that to make it 180. Okay, so all I would have to do is take 180 minus the angle I was already given. So the supplement of 60 degrees would be 120 degrees. Okay, then same thing for its complement. Okay, except complement would be they have to add to 90. So I would take 90 minus the angle I was given to find that complement to 60 degrees, which is 30 degrees. Okay, and number 4 then, we're given 45 degrees. We want to find its supplement. So same process, 180 minus 45. That's 135 degrees. Complement, those ones are 90. So what do I have to add to 45 to get to 90? 45. Okay, the last one is just the rule for finding a supplement or finding the complement. So you're given any degree measure. To find the supplement, you just need to subtract that degree measure from 180. So this would just be 180 minus that degree, which is n. So that's the rule for finding that supplement. And then the same thing for the complement. We would take 90 minus our given angle measure to find that complement. Okay, questions? Supplement, complement? All right, then we're going to look at perpendicular lines. Okay, so perpendicular lines intersect to form 4 right angles. Okay, you can see that over here. We have our intersecting perpendicular lines. We have our right angle, and all 4 of those will be right angles. Perpendicular lines intersect to form congruent adjacent angles. Okay, they are congruent, they're all 90. They are adjacent, they're next to each other. Okay, segments and rays can be perpendicular. This is my symbol for perpendicular, so you don't have to write it. Segments and rays can be perpendicular to lines or other segments or rays. Okay, Okay, so you don't have to just have lines. You can have perpendicular segments, and you can have perpendicular rays as well. So our right angle or perpendicular symbol, again, is this upside down T. You can see that right angle formed as you make it, and it indicates that the lines are perpendicular, and the angle measures are 90 degrees. So if you ever see in any type of direction where it's like line AD, and then they have this perpendicular symbol to line BC. Okay, you know that the angles formed there have to be 90 degrees then. Okay, so that's where you'd see this symbol. It won't just write out the whole word perpendicular. You'll have to understand what that symbol means. Okay, questions on that? All right, let's do some examples. 2 examples. So this is where I was talking about they'll use that perpendicular symbol. So we want to find x and y so that line PR, okay, this one right here, is perpendicular to line SQ. Okay, so if those 2 lines are perpendicular, then the measure of angle STR has to equal what? STR, if they're perpendicular. 90. Okay, and I'm going to write that box in my picture. So I know I want them to equal 90 degrees. Okay, and then angle PTQ would also have to be what? 90. What type of angles are STR and PTQ besides 90 degree? Right angle, what else? Together. What type of angle pair are they that we just talked about? I didn't hear what you said. Not a linear pair. They are supplementary, but they're vertical angles. Okay, so you can see that they're across from each other here. And they are congruent. Okay, they're across from each other and congruent there. So we want to find x and y so that this angle is 90 and this angle is 90. Okay, I'm going to do y first. Okay, I'm given this angle is 4y minus 2. I know I have to do something to make it equal to 90. So how could I set up an equation for that? Yes. 4y minus 2 has to equal 90 if I want those lines to be perpendicular. So from there, I'm just going to solve for y. So add 2. So 4y equals 92. I can divide both sides by 4. Yes, y will equal 23. Okay, now I want to find x. Okay, I know that STW and WTR are adjacent angles. Okay, I know they're adjacent angles because they share this ray in common. Now both of those angles together have to make up STR. So how could I set up an equation to solve for x? How could I set up that equation? Add them. Okay, so I can add STW and WTR together, which is 2x, and then plus 5x plus 6, and that has to equal that 90-degree angle measure. From here, I want to combine my like terms on my left-hand side. So 2x plus 5x is 7x. I'm going to subtract 6 from both sides of my equation. And then divide by 7. To get x is equal to 12. Okay, questions on example 1? All right, I want you guys to do example 2. It's not due tomorrow.
Okay.
Mm-hmm. Mm-hmm. Yes. Yep. Yep.
I'll just bring the note and show you. I think going for page 2. Thank you.
Wait, what is
Just
this
wait.
word supposed to say? What the following English?
Name the
Okay.
following angles. All right, so I'm going to go over example 2 really quick here. So you want to find x if the measure of angle D is 3x minus 12, and we know that angle D is a right angle. So since it gave you angle D is a right angle, it must be equal to 90. Okay, they also gave you angle D is 3x minus 12. So you can set that 3x minus 12 equal to 90 degrees to solve for x. Okay, and you should get x is equal to 34. And those of you that showed me, you did get that correct. Okay, any questions on how I set those problems up?